right, so we are going to start talking about the actual process of verifying identities. So what we've been doing so far is simplifying, and now we're going to start to verify identities. So I want you to understand that the process that you are going to do is essentially the same, because you are going to continue to simplify these expressions. But in the process, what you are going to be doing is you are going to be proving or showing that both sides of an equation are equal, or that they're the same for all values of the variable for both sides of the equation. So you're going to see some examples here. And now, instead of just having an expression, if you notice, it has this equal sign here. So these are identities that we are going to verify. Now the tendency is to look at this and say we have an equal sign, so we're solving an equation. And I want you to notice this little note right here. You are not solving equations. So the process is going to be a little bit different. We're just going to continue to to simplify one side of these. So essentially what we're going to do is, let's go back, transforming the expression on one side of the identity into the expression on the other side through a sequence of intermediate expressions. So in other words, we're going to continue to simplify. As with other types of proofs, each step is justified by a reason. So you're not going to have to write a reason as you did in geometry class, but these are kind of a similar thought process to those proofs that you learned and practiced and did way back when in geometry. So we are still going to continue to simplify. So these rules here about rewriting with sines and cosines, that is going to help. The other piece of advice that I will give you, and the suggestion and kind of the process that we're going to use, we're going to look at the identity and we're going to decide which side looks more complicated, and that's the side that we're going to work on. And to kind of remind us that we are not solving an equation is part of the process that I would suggest that you do when you're looking at a problem. Is I actually like to draw kind of a squiggly line down the page to remind myself I'm strictly going to work on one side and not the other, and I cannot move something from one side to the other. So this side of the identity is definitely more complicated than this one. So we are going to work on this side, this left-hand side, and we are going to rewrite it. We are going to simplify so that it looks like, and ultimately our final answer should be that we have the exact same thing on the left-hand side down here as we do on the right-hand side. And we'll talk about how you're going to show that ultimately at the very end in just a minute. So let's go through, I'm just going to go through two examples with you. We're going to look at this first one here where we're looking at sine times this secant minus cosecant of x. So it looks like we are going to want or need to distribute probably. So that's the first step that I think I'm going to do on this, is just distribute. And then I want to do what I know that I need to do in terms of rewriting in terms of sines and cosines. So I want to rewrite this expression. I'm going to keep my sines the same, but I'm going to rewrite that secant as 1 over cosine of x. And I'm going to switch back to that other color. I'm going to keep that sine the same again, but then I'm going to switch this cosecant, I'm going to rewrite as 1 over sine of x. And if you saw right away that these are reciprocals of each other, that's great. If you didn't, then hopefully at this point you realize, okay, those divide out and we are left with just a minus 1 here. Okay, this first term, if we put this over 1 and we multiply and combine that together, that gives us sine of x over cosine of x. And we know, using our quotient identities, that that is equal to the tangent of x. And then we have this -1. And guys, that's ultimately what we were trying to get to over here. So we have just gone through the process of verifying this first identity. The last step that you must show on every single one of these verifying identity problems is this last step right here. And that is that you found, or you've shown or proven, that the left-hand side, when we simplify and we rewrite it, is equal to the right-hand side. So that's your last step always. And I'm going to abbreviate that because you're going to hear me and see me say this quite a bit over the next little while. You have to write this step down, and I'm going to remind you of that by saying left-hand side equals right-hand side. So that's just my abbreviation to kind of help you remember that. Okay? So if you think about it, the advantage of verifying, these are going to get a little bit more complicated in terms of the process that we have to do here, the simplifying. But the advantage of these is you know ultimately what you're trying to get to. You know you're trying to get to this tangent of x minus 1. And so that can help along the way with kind of giving you some hints, possibly. Okay? All right. Second example that we are going to look at. This one is definitely a little more involved. But if you notice, it cleans up very nicely, because the final answer here that we should have down here ultimately at the very end is that we should have 1 is equal to 1. In other words, left-hand side is equal to right-hand side. And our right-hand side is equal to 1, so all of this should simplify and better simplify to give us 1. I'm going to erase this just in case we need a little bit more room. So let's get started on this one. I'm seeing a lot of sines and cosines. I'm also seeing 2 terms in the numerator. Kind of a few different ways that we could go about tackling this one. And actually in my notes, I have it written one way, and now I'm looking at another way that I think I would prefer to show you because I think it's going to seem a little bit easier for you. It's basically the same process, but the writing out of the work is a little bit neater, I think, with what I'm going to show you now. So I'm going to keep those tangents and cotangents for now, but I am going to rewrite on the denominator. I'm going to rewrite the secant and the cosecant. The secant we know is 1 over cosine of x, and then that's times 1 over the sine of x. So I have a common denominator, and I have this complex fraction, so I can do keep it, change it, flip it. So if I do keep it, change it, flip it with this, I want you to realize that that means that we would ultimately have this cosine of x times the sine of x all over 1. And we're going to have to multiply that and distribute that to each of these terms. So that's what we're going to do. Okay? All right, so I'm going to keep this, I'm going to kind of color code. So cosine of x times the sine of x times the tangent of x, and then plus cosine of x times the sine of x times the cotangent of x. So that's what I've multiplied here is the keep it, change it, flip it times each of these individual terms, right? Okay, and now I really need to rewrite this tangent also. I'm going to keep my cosine x tan x, I'm sorry, cosine x sine x, but I'm going to rewrite this tangent x, and that tangent x is sine x over cosine x. If it's helpful, let's put each of those over 1. And similarly here, I want to do that same process, so I want to rewrite this as cosine x over 1 times sine x over 1 times cosine over sine. And we need to see what cleans up and what we get when we simplify here. So we have a cosine x in numerator and denominator. That divides out, and we are left with sine squared x. And we get plus, over here, if you notice, we have a sine x here and a sine x here that divide out, and we are left with cosine squared x. So that sure looks like some identities. So that's our first and most important Pythagorean identity. So that would be Aria's identity and Sam's identity and Renee's identity, which says sine squared x plus cosine squared x. And we know that is equal to 1. And that is what we wanted to show or prove that it was indeed equal to. That's what the right-hand side is equal to. So I did show that left-hand side equals right-hand side. So I have finished. Voila. We'll look at some more examples in class tomorrow.